Hi everyone. So this video is about projectile motion. So we did see constant velocity motion in one dimension in the horizontal direction in chapter 2, and in chapter 3 we did deal with the free fall motion first. So basically the two-dimensional motion that is called projectile motion is the combination of free fall and vertical. So the free fall in the vertical direction and the constant velocity motion in the horizontal direction. So you have free fall in the vertical, and you have constant velocity in the horizontal direction. The combination of these two gives you the projectile motion. How does this happen? So you release a ball or an object from some height, you know that it's going to be getting faster and faster and basically falling more and more distance in each second it falls. So it's accelerating with the gravitational acceleration g toward down. So if you give this object a push in the horizontal direction before you release it, let's say it's rolling off a tabletop. Let's say you basically push this ball in the horizontal direction, give it an initial velocity, but in the x direction, in the horizontal direction. And it's going to roll off and start falling, right? It's going to start falling and hit the ground somewhere here. So when you have this constant velocity, because after it leaves the tabletop, it's going to be doing free fall in the vertical motion. So if you're looking from one dimension, which is the vertical one, you're going to see nothing but free fall like this. And the difference is that except it also goes in the horizontal motion. So if you give it an initial velocity in the x direction again, it is going to be still falling the same amount, but moves a little bit further in the horizontal direction because of this velocity you gave. So the fall amount is the same. So I'm just trying to find something like this. So the vertical fall amount is going to be the same for these two motions, like one is being released directly, the one is pushed in the horizontal direction a little bit with a velocity v0. So the vertical fall amount is going to be the same for both of them because they're falling, they're under free fall basically. That's what they're doing. They're under gravitational acceleration of Earth. So the amount that they are falling in the vertical is the same. So if this is like, let's say, I don't know, 1 meter, this is 2 meter, this is 3 meter, this is 4 meter. I'm just picking up numbers, right? But this also falls 1 meter, 2 meter, 3 meter, 4 meter. The same amount of fall they will experience in the vertical direction. The only difference is that the one that you push in the horizontal direction at the beginning is also moving in the horizontal direction, so it is going to be going in the horizontal direction as well with a constant velocity that you left it with. So again, the free fall combined with a constant velocity in the horizontal direction is called the projectile motion. Therefore, whenever you release an object with no vertical initial velocity, whether it has a horizontal velocity or not, it is going to be falling with the same amount, and in vertical direction, the velocity it's going to gain is going to be the same as well. Only it's going to be basically sustaining that initial horizontal velocity at all times because there is no force to change that velocity in the horizontal direction. So it's going to be moving horizontally with this constant velocity that you gave at the beginning, okay? So it's going to look like something like this, which we call to be a projectile motion. You can also, this is like a half projectile motion, but it is projectile motion anyways. Like if you kick a ball from the ground, it's going to do this kind of a curved path, right? You know that it's going to go up and then fall down. So projectile motion can be this full arc, or it could be anything part of it. Like if you basically throw a ball or a stone from top of a building with, like, let's say with an angle like this. So it's going to be doing this, right? So this is like part of this starting from somewhere here, right? That's part. It could also just release it with an initial velocity in the horizontal direction directly, like I explained here. It is going to be doing then like this, which is like half of it, like from here to here, right? Here to the end point where it hits the ground back. So all of these versions, like the full arc, portion of the arc, and half arc, they're all projectile motions, and which is nothing but the combination of free fall and constant velocity. That's how you basically look at the projectile motion, and basically you can solve the vertical motion separately, completely independently from the constant velocity motion in the horizontal direction. So in the horizontal direction, because it's constant velocity, it means you don't have any acceleration in the x direction, right? In the y direction, your acceleration is your g, the gravitational acceleration of Earth, which is 9.8 downward, right? Or 10. So because there is no acceleration, it basically tells you that the velocity that you gave it to begin is going to stay as constant, and the distance is then going to be whatever with that velocity it can go within the time of flight. So that's the only relation between basically the vertical and horizontal motion, the time of flight. Time of flight is defined by the height that you're basically throwing your or releasing your object. If you remember the previous video, I showed you from some height, if you release an object, what is the time of flight. And so this full version is depending on what velocity are you using in the vertical, the upward direction, so that you basically find the time of flight from reaching to vertical velocity 0 here. Whereas you have a horizontal velocity, I'm going to call this Vy, and the horizontal velocity. So in the projectile motion, because it's two-dimensional, you have a vertical velocity and the horizontal velocity. Horizontal velocity is constant, that's why I wrote it here. There is no horizontal force on these objects. And the vertical velocity experiences the gravitational force of Earth. Therefore, if you throw anything with an angle like this, which means you're giving it a vertical initial velocity and horizontal initial velocity. So this horizontal part of the velocity is not going to change. It's just going to be carrying it toward right at all times of this, every moment of this motion. The horizontal velocity is the same. It's constant. Okay? And the vertical velocity that it started with, the initial vertical velocity, is going to be used to climb up to 0 value on the top of this arc, and then it's going to be accelerating toward down with the gravitational acceleration g. Okay, so because we're at this level of physics that we don't do vector calculations, you're never going to be given like this velocity, what is the combination of this vertical and horizontal components or anything like that, because that requires vector addition. But you might be given some questions with giving them directly, saying that like initial vertical velocity of an object is this, initial horizontal velocity of a projectile motion is given as this number. So what you need to know that the horizontal part of the velocity is never going to change. Whatever it started with, it's going to carry out its motion throughout this whole motion with that value. The horizontal velocity is never going to change. And the vertical part of the motion is completely independently doing the free fall motion. So whenever you look at this projectile motion questions, you really need to separate these two dimensions in your mind and analyze them accordingly. Again, the horizontal motion is a constant velocity motion, and the vertical motion is free fall. That's how you look at the projectile motion. And just to keep the conversation short, let me just do one more one little example. This is basically, let me get rid of this. So the example is this. Let's say the vertical component of the initial velocity was given as 20 meter per second, and the horizontal components, I'm going to call them 0, 0 because this is the initial values that are given to you, 10 meter per second. So what you need to know is that, once again, throughout the whole motion, this 10, value 10 is never going to change. So whatever that it started with is going to go with it. In the vertical, you're going to be dealing with gravitational acceleration. And so let's say, when is it going to be reaching to the top position, right? Let's say you are given these two initial velocities in vertical and horizontal, and thrown from the ground. When is it going to start falling down back? How much time is going to spend to climb up? Let's say the time from here to here, if this is point A and this is point B and this is point C, is going to be, what is time from A to B is the question. So what you know is that vertically on the top position, your velocity is going to be 0. So what is the velocity formula? It's v0 plus at, right? And so your final velocity, we're talking about the vertical again, separate these two as if they're completely independent, which is the case anyway. So in the vertical motion, your final velocity is going to be 0 on the top position, which is the B, right? And this is the initial, which you were given as upward 20, so because it's positive, plus minus 10, I'm going to use 10 meter per second square for G, times T. So you need to solve for T, right? So T is going to be then 2 seconds. So your time of flight up to top position is 2 seconds. And so you can figure out that this is a symmetrical motion. It's going to spend like 2 seconds to fall down also, because whatever the height that is going to climb up during this 2 second could be a question. Also, what is this point B's height? Could be a question. So it is basically the distance, right? It's displacement in the vertical direction. And displacement formula was v0t plus 1 over 2 at squared, right? So if you're going from A to B, again, I'm just looking at the first half, the distance, or in this case, the height that it's going to climb is going to be v0 was 20 times, it's going to fly 2 seconds, which I found out, plus 1 over 2, a is minus 10, times t squared is 4, right? Let me write it as t2 squared, which is 4. So if you do that, you're going to come up with 20, right? 20 meter, because 40 minus 20, it's 20 meter. So this height here is basically 20 meter. So you can solve the other half starting from this, but I believe this should help you for projectile motion questions if you have any numerical questions for projectile motion. And once again, the horizontal motion doesn't change its velocity. It's always going to be 10 meter per second toward right. And you can find the range, that's called range actually, the whole horizontal distance. And in this case, from A to B, right, from A to B, what is the horizontal distance? Is going to be then constant. Velocity means v times t is the distance it's going to cover. So in 2 seconds with 10 meter for each second, your range is going to be 20 meter in the horizontal too. So this range for the half of this path is also 20. Okay. So this here is basically distance is v0 times t, because your motion in projectile motion in the horizontal is a constant velocity, and therefore you use basically this d is equal to v0t formula, because you don't have any acceleration. So the horizontal distance is going to be 20 meter. I hope this helps.